If you've ever wondered what DevOps really means, or why it has become one of the most critical practices in modern software development, then you're in the right place. In this video, we'll explore why DevOps was created in the first place, what it actually looks like in real-world practice, the key challenges it solves, and how DevOps compares to SRE or Site Reliability Engineering. So let's dive right in. In the early days of software development, two distinct teams handled the journey of an application: the development team and the operations team. Developers were responsible for designing, building, and coding the application. Once they were done, they would hand things over to the operations team, who tested, deployed, and maintained the application in production. This sounds logical, but in practice, it caused delays and inefficiencies. Developers will wait for feedback, operations will struggle with unclear deployment instructions, and often the two teams were working on different timelines entirely. Development might be knee-deep in the next project while operations was still fixing bugs from the previous one. This disconnect led to a lot of waiting, miscommunication, rework, and frustration. Projects took weeks or even months, longer than necessary to ship, so the idea was born. What if these two teams work together continuously instead of in silos? This is where DevOps came in. So what is DevOps? DevOps is short for development and operations, but it's much more than just combining two departments. It's a cultural and technical movement designed to improve collaboration, increase automation, and accelerate the software delivery process. The DevOps approach is often symbolized by the infinity loop. That's because it represents a continuous cycle of planning, coding, testing, releasing, monitoring, and feedback, all happening in a tightly integrated and automated fashion. So instead of throwing code over a wall to operations and hoping for the best, DevOps brings both sides together from the start. The goal is to create a seamless pipeline that allows for frequent, reliable releases with fewer errors. So what problems does DevOps solve? One of the biggest problems DevOps addresses is the gap in communication between developers and operations. Developers want to release new features quickly. Operations want to keep systems stable and secure. It's easy for these priorities to conflict. Without DevOps, deployments are often delayed with unclear documentation, manual steps, or security approvals that take days or even weeks. Testing may be done manually, and if a bug or failure occurs in production, it takes even longer to trace the cause and fix it. DevOps introduces a shared responsibility model where developers and operations work together from the beginning. Automation replaces slow manual steps and helps reduce human error. But it doesn't stop there. This collaborative approach also includes security and testing teams. By integrating these practices directly into the pipeline, every release is not only fast, but also secure and well tested. So how does this play out in practice? Let's work through a typical DevOps lifecycle to see how it all works together. It all begins with planning. This is where product managers, developers, and other stakeholders come together to decide what features to build and how they will measure whether those features are successful. Next is development, where developers write code and collaborate using shared repositories like Git. Version control helps them manage changes, work on different features at the same time, and safely merge their updates. Once code is ready, it moves to the build stage. Tools like Maven or Gradle compile and package the code into deployable artifacts for Java-based projects. In JavaScript-based projects, tools like NPM or Webpack handle bundling and dependency resolution. From there, automated testing tools like Selenium check for bugs or errors, both manually and through continuous integration pipelines. If all the tests pass, the application is ready for deployment. This means moving the code from a development or testing environment into a live production-ready system where real users can access it. At this stage, Infrastructure tools like Docker are used to package the application and all its dependencies into containers. These are lightweight, portable units that can run anywhere. Kubernetes then takes over to manage and scale these containers across multiple machines, ensuring high availability and performance. Then tools like Terraform and Ansible help automate the setup of servers, networking, and cloud resources, making sure everything is configured correctly and consistently. Together, these tools ensure that the application is deployed smoothly, reliably, and in a way that can scale as user demand grows. Once deployed, the application is monitored. Tools like Prometheus and Nagios keep an eye on the system health, performance, and uptime. Any issues detected are sent back to the team as feedback, which completes the loop and informs the next planning phase. The DevOps lifecycle wouldn't be possible without the right tools. Let's take a look at some of the most commonly used technologies in DevOps. Version control systems like Git help teams collaborate and track changes. Build and package managers like Maven, Gradle, or NPM help automation during compilation. CI/CD tools like Jenkins, GitLab CI, or GitHub Actions automate the testing and deployment pipeline. Containers and orchestration tools like Docker and Kubernetes manage environments efficiently. Infrastructure as code tools like Terraform and Ansible allow teams to spin up entire environments with code. Monitoring systems like Prometheus, Grafana, or Nagios track performance in real time. Together, these tools form a pipeline that can go from code commits to production deployment in minutes, not days. With all these tools and processes, it's no surprise that DevOps has become a specialized career path. Let's look at DevOps as a role. DevOps has evolved from a philosophy into a defined career path. Today, many companies hire dedicated DevOps engineers. These professionals don't necessarily write application code, but they are essential to building, maintaining, and automating the entire delivery process. From configuring infrastructure and writing scripts to managing cloud deployment and monitoring systems. DevOps engineers make modern software delivery possible. They need a strong understanding of Linux, networking basics, security, containers, and cloud platforms like Amazon Web Services, Microsoft Azure, or Google Cloud Platform. Familiarity with scripting languages like Bash or Python is also a must. As DevOps engineers take ownership of more than just code, their responsibilities often extend deep into infrastructure and deployment. That's where cloud platforms and infrastructure as code comes in. Before cloud computing, setting up infrastructure meant buying physical servers, plugging them in, installing software manually, and wiring up networks. It was time-consuming, expensive, and hard to scale. Today, most DevOps teams use cloud platforms like AWS, Microsoft Azure, or Google Cloud. These platforms offer on-demand access to servers, databases, and storage, so you can launch resources in minutes all through the internet. But it gets even better with infrastructure as code. Infrastructure as code means writing code often in YAML, JSON, or a domain-specific language that describes your infrastructure like servers, networks, and databases. So instead of clicking around in a web dashboard to set things up, you write code in a configuration file which declares or describes the resources you intend to create, update, or delete. When you run the configuration file, the cloud provider builds the environment exactly as you have described automatically. This means you can create and destroy test environments in seconds. Your setup is repeatable and version controlled, just like application code. You can scale infrastructure up or down quickly using tools and automation. Tools like Terraform, AWS CloudFormation, and Pulumi are popular for defining infrastructure this way. So whether you are launching one server or a full-scale global app, infrastructure as code gives you speed, consistency, and control, all crucial for modern DevOps. If cloud platforms and infrastructure as code are the foundation of DevOps, then CI/CD is the engine that keeps things moving smoothly. CI/CD stands for continuous integration, continuous delivery, and sometimes continuous deployment. These are practices that help teams release software faster more reliably, and with fewer errors. So let's break it down. Continuous integration (CI) is a process where developers frequently push small changes to a shared repository. Each change automatically triggers tests to make sure that it doesn't break anything. This keeps code quality high and helps catch bugs early. Continuous delivery (CD) means that once the code passes all tests, it's in a state where it could be deployed at any time to a production or staging environment. Deployment step may still require manual approval before release, but the code is always ready to go live. Now, continuous deployment takes things one step further. Every change that passes all tests is automatically deployed straight to production with no manual intervention. This ensures users get new features and fixes as soon as they are ready. The key difference between continuous delivery and continuous deployment is that continuous delivery requires manual approval before release to production, while continuous deployment automatically deploys code that passes all tests straight to production with no manual intervention at all. Together, CI/CD leads to shorter release cycles, fewer bugs in production, and faster feedback loops, all of which are essential for modern development teams trying to move fast without breaking things. Think of CI/CD as a factory pipeline. New code comes in on one side, gets tested, verified, and safely pushed out the other side, all with minimal human effort. All this sounds great in theory, but what does it look like in the real world? Companies like Netflix, Amazon, and Walmart have all embraced DevOps to accelerate software delivery and stay competitive. Take Netflix, for example. To ensure its platform stays resilient, Netflix created a toolset called the Simian Army, which is a suite of programs designed to test system reliability. One of these tools, known as Chaos Monkey, randomly shuts down servers in production on purpose. Why? Because Netflix wants a system to automatically recover without human intervention. This kind of intentional failure testing ensures that the service remains robust even under unpredictable conditions. Amazon, on the other hand, deploys thousands of changes every day across its global infrastructure using highly automated DevOps pipelines. Walmart uses DevOps to handle massive seasonal traffic surges like Black Friday without downtime. This level of speed, reliability, and innovation is only possible with a mature DevOps culture, one that prioritizes automation, continuous improvement, and a willingness to experiment. Even if you are not building the next Netflix, these principles can be applied at any scale. Start small, automate what you can, and build a culture that supports learning and adaptability. Before we wrap up, let's quickly touch on Site Reliability Engineering, or SRE. SRE and DevOps share the same goals: faster releases, reduced downtime, and more reliable systems. But they approach these goals in slightly different ways. While DevOps is a broad cultural and practical philosophy that promotes collaboration between development and operations teams, SRE is a more structured engineering discipline that originated at Google. It applies software engineering principles to operations problems. SREs focus heavily on things like reliability, automation, monitoring, and defining service level objectives, SLOs. These are clear targets for how reliable a system should be. You can think of SRE as a concrete implementation of DevOps with its own tools, methods, and measurable targets. In fact, most companies today employ both DevOps engineers and SREs, working side by side to deliver fast, reliable, and scalable systems. So that's DevOps in a nutshell. It's more than just a buzzword. It's a set of practices, tools, and cultural values that help teams deliver better software faster. If you found this video helpful, please hit the like button, subscribe, and drop a comment with your DevOps question. Thanks for watching, and I'll see you in the next video.